100 years ago was the last overflow of Halemaumau. This is what Kilauea looked like 100 years ago. And it also hosted a lava lake within Halemaumau crater. And yet it was much different than today. September of 1920. And the reason I like this photograph is you often do see this inner part of the lake photographed where you see is little islets and higher islands and larger peaks in the side that they're calling crags, in fact, over here. And you actually can see this is all within, I'm going to pan over to the right here further and further. This is all within a much bigger crater wall right in there, to the point where you have other separate lava lakes on the side over here. You guys can see that. And zoom out a little bit and across. Show you guys a view in 1920, right? So the previous 4 years before that had been an era of many overflows of the lava lake. The lava lake had been flowing over many times. So I'll show you guys a graph at the end here. But all of that was happening much higher than today's current lava lake. Today's current lava lake is somewhere around 1,200 and 1,300 feet below where this eruption was happening 100 years ago. So we still have a long way to go to fill up to the previous lava levels like we had back in 2018. And that's more or less the lava levels we're discussing when we're showing you guys this activity in here. Jaggar himself was the one who documented most of this, and he said that March 1921 eruption would long be remembered as the most tremendous fiery display of Kilauea overflow of this Hawaiian cycle. Never in a past decade had Halemaumau presented so brilliant, large, and continuous a sheet of liquid lava overflowing its rim. So that's what we have to come here. I'm kind of setting the scene of what it actually looked like beforehand. And so another way to imagine what was happening here and to bring it back to what our lava lake looks like now and all these different terraces and features and why it might matter. Back in those days, they used different terms. They used a term called epimagma and pyromagma as different kinds of lava that had different textures and appearances and properties, in fact, as well. So let me read you guys what Gordon MacDonald, who was the third director of HVO, describes along with Douglas Hubbard, who was a naturalist at National Park, when it published many years later. He said this: "The upper end of the conduit contained a plug of semi-solid lava, resembling A'a in appearance, and known as epimagma. Fissures extending through this plug allowed liquid lava from below to rise to the surface, where it formed a shallow pool about 50 feet deep, on top of the epimagma. The lava of this pool was termed pyromagma. It was thinly fluid and free-flowing and congealed to form pahoihoi. Both the pyromagma and the epimagma were free to move up or down in the conduit, either independently or together. Owing to its greater fluidity, the pyromagma, the more liquid lava, generally rose or sank more rapidly than the epimagma. Crags of the epimagma projected through the pyromagma as islands in the lake, and at times the lateral shifting of these crags gave the false appearance of islands floating in the lake. The pools of liquid pyromagma continually changed in form, size, and number, with changes in the depth of the pyromagma and the configuration of the top of the semi-solid plug on which it rested." So that's the deal there, and let me advance here and show you guys a map made on March 14th, just before this happened. So this is a view of the Halemaumau lava lake, and the white areas are the ones with active lava, and the black areas are showing topographic lines on them here. So before I get into the actual layout of what's going on here, you can see at a glance there's a lot of different lava ponds or lakes. About that shortly, but let's look at down here. He includes a cross section as well, right over here. So what he's saying is there's a semi-solid plug of lava that has cracks in it through which the liquid lava is able to rise and overflow on top of it. But that this whole plug below can also be deformed as magma, essentially the lava is erupting underneath it and bulging it upwards. So it's still magma at that point. It's almost like it's inflating, injecting underneath it. before it can crack through the gaps and make it onto the surface. So when this eruption begins, first thing that happens is all this plug starts rising before the lava underneath it can break through it and flood the whole area and drown it all. And that's the sequence we'll take you guys through here. But before I get to that, just to mention, this terminology here, they add back in 1951, the feature that distinguishes a true lava lake from a mere pond of lava accumulated in a depression is a presence in the lake of a distinct circulation of liquid lava from depth into and through the lake and back down into the depths. So by those standards, our lava eruption we have now is a mere pond, quote, rather than a true lava lake. But maybe this is a little bit retrospective since we're still talking about what these different terms for puddles of lava in different shapes happen to be. Yeah, so all that said, we have here in our map from March 14th, 1921, our central lake, right here in the middle. Central lake. And we have a west pond. And we have an east pond as well. We also have a southeast pool. And we have a southwest arm. So you can see the terminology is all over the place there. 2 ponds, 1 pool, 1 arm, and 1 lake. They're all just puddles on top of this plug of semi-solid lava they're calling epimagma. That's the gist of it there. So that's kind of the lead up to it. And Jaggar describes what was happening earlier in the month like this. At the beginning of March, the continued subsidence of the lava in the pit made this scene surprisingly impressive owing to the great inner crags towering above the 5 lava lakes. The walls around the several lakes were sheer precipices, 70 feet high in places, and the rim of the pit stood 90 feet above the liquid lava. So that's that first view I showed you guys there, and we can show you guys a little bit of a different view here. The top, the original panoramic and colorized by Dane here below. I might have to come in a little bit so you guys can see some more of the detail without as much as the breadth here. So there are those crags.
Colorization really helps in there. Makes it look like it's not from the 1920s right away.
Yeah, it really helps to connect it to us, I think, is the important thing, right? Even if it's not exactly true, it's a lot, it's interesting. You can see the colors really evoke a certain kind of connection. And then the details you see also evoke some more science you can do over there, so that's really interesting. Interesting to see them both here side by side. So mahalo, Dane, for all your work on that today. And yeah, that's the view of it there, right? So that 90-foot drop into the lava lake. But as the lava levels start to rise, Jaggar describes something amazing that happens regarding an islet that became an island and then tipped over. So let me first just point out back on this map, on this map right here, let me get my color so you can see it. Right in the middle, this little black spot right in there, that is the little islet that we're discussing right here. It was just a small little thing, seemingly innocuous, floating in the middle of that central lake. And it became this. And I will read you Jaggar's account of that. An astonishing transformation had taken place in the new islet of the central lake. It had lifted bodily by a swelling upward of the lake bottom around it, to become an immense hill with a flat islet standing like a thin-stemmed wineglass on top. This mass stood 40 feet above the lake. The tilted toadstool on top threatened to fall at any minute. The top of this mushroom tower had been a low flat islet in the lake, which as usual was 30 or 40 feet deep, over an epimagma bottom. The epimagma was arched up suddenly as a function of the sudden rising of the liquid lava that followed. So just preparing you guys to understand what that sentence actually meant there for the last few minutes here, and that's what he's talking about as he's seeing this, right? This was a part of that semi-solid plug of lava And as that thing bulged from below, the island attached to it was tipped over within the lava lake. So this was a sign, and most notably, because this thing rose faster than the lava level was rising. Right? So let me continue his description here. The lower portion looked like an elephant, rounded and black with a smooth surface. The whole mass had lifted faster than the lake and had filled a great part of the lake area. The hourglass effect on top was where the stem of the islet had narrowed just below lake level. And then below that, evidently the topography at the bottom had widened out. The whole mass was toppled over toward the west. And imagine the view. He was talking about this little islet rising out of the lava lake for long, long afterwards. In fact, this event, this thing rising out of here, was one of his key observations to how the whole process on Kilauea Summit and its lava lakes actually worked. So it was a really impactful eruption on Jaggar for various reasons. This is all in a build-up still. So on the early hours of March 18th, 1921, there was a bright glow coming from the crater. Earthquakes ticked up. Harmonic tremor started showing on the early instruments. And Jaggar made his way back to Halemaumau. And he describes what he sees when he arrives there. Was this. As follows. He summarizes the whole activity by saying, an intense effervescence following the previous rise of the crags made Halemaumau overflow and renewed the big flows at the rift vents on Kīlauea floor. Though much more sudden, this eruption was not unlike the December and February risings. So what you guys are seeing here is a fountain, individual jets 40 feet high, rising through the surface of this rising lava lake and piling up spatter deposits on the side over here. March 19th, this is the following day, but there's not a whole lot of photographs. This is one I have to show you guys of that phase of it. He describes the activity renewing as such. At 12:30 a.m., just after midnight of the 17th, there was a quick breakup of crusts and rising of the lakes, which increased the brilliancy of the pit remarkably during an hour. By 2 a.m., the fountains were in view from the volcano house. At 5 a.m., the fountaining of the west, central, east, and southeast pools was in plain view from the observatory, and a brilliant glow was seen beyond in the southwest region. At 6 a.m., the pit was overflowing its northeast lip. At 6:45 a.m., the rider reached Halemaumau. And he's booking it all the way there, and he finally gets there. 6 a.m. And he sees a whole different view. I'll show you guys this view first. From the rim of the pit at the south pressure ridge, the most sensational change was found to have taken place. In contrast to the dull-crusted lava of the previous evening 40 feet down, the lakes were now 4 feet below the east margin of the pit, all merged into a small sea of fountain lava with the crags standing high as islands, and the liquid was brimming over the southwestern and northern sides. Southwest Lake, South Channel, and Southeast Pool had numerous large fountains and ballooning skins. The southwest island was submerged, and the south table crag was tilted westward, its southern cliff only 6 feet high. The liquid was rising rapidly. Here's the original view, all these photographs by Jaggar himself. And here, colorized view, that now higher lava surface right in there. And you see the tops of those crags looking like little islands floating, but really, when lava levels were lower, these were big structures rising from below the lava, like part of that semi-solid plug. Interesting views there. 100 years ago. The several pools of lava of Halemaumau were marked only by fountaining areas, with fountains not so numerous as in December, but with more large centers of effervescence separated by surfaces as skin. All the crags were islands. The hollows north and northeast of Halemaumau had filled evenly with an extension of the lake, backed by a new rampart of slabby crusts. Interesting, slabby crust, we saw that today already in photographs. and this during the high level greatly enlarged the actual lake surface beyond the limits of the pit. So, showed you guys. I can get it back here.
Did we have in that the map view, the top down? Did it give dimensions of the lake? Like
this whole thing, end to end, is probably 1,200 feet or so.
Okay.
So maybe a quarter mile ish, somewhere in there. A little less. So there's a lot of small stuff and a lot of stuff happening in a fairly small area compared to what we have happening today. A lot smaller than today. All right. So here's a view. This is the March 14th map, and all the pools are clearly separate bodies here, and you see all these peaks and all this topography shown in here. And I'll jump forward for you guys to the one from April 4th. So by this point in time, the lava was already receding, but this gives you a much better idea of what it was actually like during that high flood on March 18th. You see here, most of it's all connected. And earlier, lava was filling this gap as well, all through here, and overtopping this part as well, and filling all through here on this backside, all the way to here. All this was all filled in, all the way to the edge, and to the shelves up in here. And that was all liquid lava. That was the extent of it there. So here's how he describes that, and I'll leave this map up so you guys can try to imagine. Right? Streaming in the east pond area was southward, directly away from the skin, which separated this current from the pool. Like that. Where the streaming was northeastward. Large fountains were increasingly clustering in the southeast pool region. So this thing's spilling over this way, it's spilling over this way. And there's, in this area over here, more fountaining beginning. The castle crag had changed shape. This one over here. The north peak of the northeast crag mass had slumped. Nothing was left of the new island in Central Lake. The whole thing that fell over is totally reabsorbed or redeposited. Very large fountains had started a cauldron of gas release and depressed lava in what had been the east corner of the southeast pool. Towards this focus, there were inrushing currents from the east pond, south channel, and Central Lake. The action increased until the stormy center of activity was the most conspicuous feature of the eruption, with the inflow from the other pools becoming frequently cascades into the vortex at the cauldron. The immense fountains built a black glassy rampart grotto and flung up clouds of droplets and filaments that formed deep cindery beds to leeward, southwest of Halemaumau. It does also notice that those glassy ramparts are full of up to quarter-inch size olivine crystals, and it's something that we'll come back to later on. This was a flow famous for its olivine content. The southeast cauldron and its ramparts had assumed the character as a sinkhole, with a line of enormous fountains across the southeast pool in a southwest-northeast direction, flinging showers of spray 80 or 90 feet away. The lowest level of the foaming pool stood about where the east cove of the southeast pool had been, and directly under the southeast station, where the ground had been flat, much frequented by visitors. The fountains made a swishing sound like the surf and had the quality of the Mauna Loa fountains, only the lava was much more viscous. Every now and then, spurts of brown fume violently blown up from below rose through the storm of fountaining. Individual fountains were of the perpetual type, with flings 15 to 20 feet high, but as much of the time the cauldron was a roaring abyss of hundreds of fountains, indistinguishable as units. The violent fountaining was concentrated at the West Crag Grotto and the cauldrons, with green and salmon fume rising and the intensity changing from time to time. The southern part of Kilauea crater was aglow with brilliant meandering streams and the unchanging mottled dome of glowing melt, welling up in artesian fashion at the rift. There's a lot going on there. A lot of different activity here. And this is Jaggar's night view. Not the best image, but there's not a whole lot of them. Night view of the south cauldron of the March eruption of Halemaumau. Here's a spatter rampart in the foreground, on the edge. And this is the pit that all the lava is draining into. You can't quite make it out. There's a lava falls pouring there, lava fall pouring in there, and then one from this backside also pouring into that hole right there. So Jaggar's words again. Kilauea was never more spectacular. At Halemaumau, the gas release which followed the overflowing produced 3 sinkhole cauldrons inside the pit arms of the lake. These developed enormous clusters of roaring fountains, hot greenish-brown fume, inrushing cascades, and upthrown slaggy flings that formed ramparts. Showers of grit and spun glass fell to leeward. The new rim of Halemaumau was almost unrecognizable. The eruption continued steadfastly, with pit in adjustment to overflow, and the crag islands, which had risen less than liquid, began to disappear. So that's another view there. I'll show you guys a map. And this is our Google Earth of our current caldera, our current collapse pit, our current Halemaumau pit. It's about like that. The previous Halemaumau pit was in the area of here, and as I mentioned, it was much, much smaller. The overflows escaped from the rim of the pit on 3 different sides. The overflow northeast swept down for a mile in a volcano house direction, crossed the trail, and made A'a lava at its front. This flow also consumed the nearby tool hut. Its contents were water barrels, crowbars, shovels, hammers, and some pipes, lumber, and furniture belonging to the observatory. A little bit more zoomed in here. The longest flow was pouring all over the southern end of Kilauea caldera and out through a gap in a wall, where it advanced 1/3 of a mile into the desert and stopped. The inner caldera had been breached at an elevation of 3,625 feet above sea level. That's right here. Lava flow was aided by a cone 500 feet southwest of the lake, somewhere around here, known as the Red Sotafara, which also connected to the lava column and erupted with the rising lava. So to clarify, zoomed in here, the lava lake was over here, and it was overflowing, redirection. And there was also a small little cone off to the side that was connected through a crack or something to the lava lake. And when the lava rose through the lava lake, it also rose through that crack and poured out the side over here. And together, the overflow of the lava lake and of the lava coming out of the red Soltafara both fed this gigantic flow that piled against this cliff here at the back wall, south wall of the caldera. And it piled higher and higher and higher and higher and higher until it finally got through this little gap and flowed out the gap about 1/3 of a mile over here. So I call this the inner caldera because there's another cliff back here. That's what we call it, the Great Caldera, the outer caldera. It's the true edge, and you can see that this other cliff has also kept in part of this flow in 1921. And in later times, let me advance here and show you guys that Geological Map 1921 is this yellowish unit, and this area down in here has since been covered by 1971 and 1982 lava, right? And all of it piling against this cliff edge of the caldera wall over there. So the red Sotafara. Here it is, in December 28th, 1920, before this big overflow and uprising, and some people. I like this image because it's got the people for scale. Right over here, here is our vent. You can see quite a lot of fume. And what you can't tell is a lot of this light-colored stuff is a lot of that gypsum and quartz and other opal deposits from persistent degassing and probably some interaction with steam and water in this area as well, right through here. And so he describes bright orange, yellow sulfur, and selenium in the foreground. And some recent overflows also come around that cone as well, over here. Right, so that's the before. And Jaggar afterwards went and took this one. So this is the black and white, just so you can kind of compare this little knob right here, that little knob right there. So here, this is the lava dome, the standing lava dome, which formed at that outlet of that vent. Right, and once again, back, people for size, lava dome, and finally, I'll show it to you guys as Dane colorized it. Jaggar describes what it took to get this photograph. Right, here's what he says. For photographic purposes, the standing fountain was approached within 25 feet. The liquid incandescent dome stood 9 feet above the ground level and surmounted an open pot 20 feet wide towards the southeast, where the gush of heavy fluid boiled over in a long curve with standing waves and fed a steadily running torrent. I was able, from a monument which stands a few hundred feet southwest, to walk rapidly to the bank of the torrent over hot shells and take a photograph. So he's describing his adventure there scientifically, of walking across shelly, hot pahoehoe lava that was still cooling to get to the edge of the actual active channel here and take his photograph. So, mahalo for the effort back 100 years ago, Mr. Dr. Jaggar.
That's been pretty nuts. I know what it was like walking on Shell Pahoehoe after the 2018 eruption off on the sides of the lava river, and it was nothing friendly, and it wasn't active at that point.
Yeah, exactly. Yeah. It was another level with these guys, right? You know, he before this whole sequence begins, he finds ways to crawl down into the pit and walk around on the different ledges and look at stuff close up. And, you know, a few months later, the whole thing gets flooded with lava and everything just vanishes, you know. Not only places where he used to climb down to the very bottom part, but where he was taking tourists a little bit higher up than that. All of it flooded by the whole surge, right? So it was really a whole different thing. We're going to climb down into the pit as close as possible with rope ladders or whatever it takes. Yeah.
The cowboy times.
Yeah, different era. Yeah, for sure. So now I'll show you guys a photograph of an area known as the Italian Cliff. It's over here. And this is the south part of Kilauea. This is that smaller inner caldera wall that you see. And what you're seeing is this lighter color stuff is the active lava flow that's pouring out and piling against this wall. Right? So they note that this is a locality of algae. Right, so it also indicates steam or fresh water, and you know, now after 2018 and this collapse, we do know that there is perched water and some impounded dikes in the southwest rift zone area, exactly right around here. In fact, we might have draining of water from this exact zone. So at other points in the past, this was all covered in lava and it was steam vents and it grew algae, and not just algae, but some rare ferns as well. So Jaggar describes this photograph here. The smoking place on the cliff is where the fresh overflows are filling the whole south end of the greater crater and spreading to the south bay so as to destroy the blue-green algae and the solfataric deposits which characterize this ash section known as the Italian Cliff. Also, it was here that the rare primitive fern Ophioglossum had been found. So the natural primitive fern was found in the area, but it was all destroyed by this eruption. Fortunately, it was found again years later, not far from here, some different cracks, right? But that's a whole other story. We'll leave the botany for those more qualified than that. And show you guys another panorama here. So this is now March 21st, by which point in time the lava has started to drain a little bit. That's centered here. And read you guys Jaggar's account once again. There was a slight lowering of the lava lake, and it had become a Niagara of complicated lava falls pouring into the northern and eastern cauldrons. As the greater cascades were from 50 to 100 feet wide, and the fall fully 40 feet, something of the grandeur of this fiery maelstrom can be imagined. The whole pit was resolved into 3 parts: quiet source pools southwest and west, rapid torrents center and southeast, giant cascades and churning cauldrons north and east. And there's another phenomenon that he describes, which you don't have images for, so I'll leave you guys looking at this. Here, I'll zoom it in a little more. You guys can imagine what's happening over top of this lava lake.
You're an artist. Open Microsoft Paint.
That's I can draw it on there on top of that, right, with my little on-screen jar. But this activity was accompanied by whirlwinds generated by uprush of hot gas, and deposits of glass droplets, olivine crystals, and spun glass were piled up near the ramparts. The actual whirling movements carried shells and fragments of glowing basalt hundreds of feet into the air, becoming miniature tornadoes, and lifted the fountains and burning gases into streamers of fire. These whirls made loud roaring noise, and the larger fragments fell several hundred yards from the pit. The calm, cloudy weather caused the finer stuff to rise to great heights and fall as grit and wisps of Pele's hair many, many miles away. There you go, Dane. Another early lava-nado account.
There you go.
Count number 1 of that sequence. He's got another one, actually. Oh, yeah. But I mean, the first one, the whirlwind developed a basal breadth of 800 feet, migrating across the east rim of Halemaumau. The moment it acquired the loose grit available on the older lava surfaces, it became black with debris, which it whirled around for a few moments and then expended itself and disappeared. Another strong whirlwind started in the south cauldron and migrated back and forth over the hot rapids inside the pit. There you go, Dane.
There we go. Pretty intense stuff.
Fragments were carried up to 700 feet. The lava was drawn up into what appeared to be streamers of red flame. Whenever the spout migrated over a crag or the brink of the pit, it became blackened with lava particles. After action for 20 minutes with loud roaring noise, this world expended itself. Larger fragments seen close at hand as they struck the ground were red hot and pasty. One of these on the west side of the pit was 52 inches long and 20 inches great its width. It must have weighed over 40 pounds. Many fragments weighed 5 or 6 pounds and consisted of shreddy coarse lava, folded and twisted. There were stringy pieces of cigar shape. Others were irregular, including many light lava shells. A tendency to elongate form, twisted once in a figure 8, was common. The substance came from papery crusts and from flings of the central fountains. Much scoriaceous glassy lava was blown about, which gave rise to false reports of an explosive eruption. Hot whirlwinds are common here, but these were unusually large. So interesting there, that little note at the end, that even then, false reports of explosive eruption, there was not even any social media going on, but people see stuff falling from the sky. It must have exploded, it must have exploded. And word spreads and coconut wireless.
That's nothing new.
So at the end of the month, started a rapid sinking way of the lava column to the 100-foot level. This was a closing stage of the eruptive crisis, and the fire pit resumed its more normal condition, with scores of fountains, numerous islands and crags, lava cascades pouring into wells, and shifting surface currents across the incandescent lake. That's their normal back then, right? 4 years of high lava level activity. The crags and lake lowered 10 feet or more per day. Whirlpool and shifting sinkholes formed. The crags and islets increasingly emerged. Fume grew thicker, and lines of traveling fountains became conspicuous features. The noise, glow, and heat greatly diminished. The flow on Kilauea floor ceased when the subsidence began, and the impressive underground chambers were revealed at the 2 source cones, with wells surrounded by glowing stalactites and banners of pale flame. So return to the red Soltafara here, colored once again by Dane. And here it is glowing out of its pit after the fact. And as the lava drains away, this is many months later, you see there's been a rearrangement of exactly where the crags are the highest and how the ponds all connect, and the whole layout of the whole thing actually becomes altered quite a bit. I'm going to zoom in on it a little bit more here. All right, so that's the account of that. It was in the end about a 1-week event, right? And they called it an eruption, but it's really an overflowing event because there was lava at the surface before that erupting, quote unquote, but they thought that didn't count. In those days, it could be picky enough, and so that doesn't count. And when it surged up through that, that was an eruption. So that's what this event has been described as an eruption in those terms. As a surge through that, above that background level. And going back to background level meant there was still lava on the volcano, although it wasn't to overflow that rim ever since then. So let's look at the geologic map here today. And we'll start with this pre-collapse geologic map. Just to show you guys, there is 1921 lava here on this map down over here on the south part. And also there's a bit of it showing the northeast and a bit of it showing here to the northwest. Yeah, some of this was covered in 71 and 74 by these flows in this area over here. So that was actually continuous this way, all within the pit, and of course all this was blown out by the explosion in 24. And the northeast branch that went towards Volcano House is still over here. And that's before the collapse, which is to say that this flow has been accessible and people have been able to do more modern science in the times since then. There was science done back then as well. We'll come back around to that. But to start off here, there have been samples collected of this 21 flow. And let me move here to our current geologic map and collapse. So that 1921 flow, there's a part of it underneath a road on that downdrop block right over here. There's a piece of it on this western block over there. There's a piece of it over here on this 900-meter elevation downdrop block right in there. And there's a piece on an upper downdrop block, the largest one, that now is truncated by this cliff. And north of there, no more. So now it's fully within this inner pit, and 1921 flow is not visible on this upper caldera floor any longer. So studies can still continue, but you see that it's a lot less accessible than it was before the collapse, even though there are still chunks of it up there. Of course, I'm not showing you guys off the bottom of this map. There is more some up here, up on the rim. This map is not showing it, but in an earlier geologic map, I showed you guys where that arm reached to the south towards the inner caldera wall, right in there. So what have we learned from taking these samples? This is a paper, 2019, by Petruska et al. And we've shown this before. And he's comparing on this panel on the right over here what was a typical pattern or the actual magma bodies and their interactions coming up to the surface between the years of 1912 and 1954. Right? So it's can't quite see all of it there, but I can read you guys what the numbers actually mean, right? So number 1 was 1912. Number 2 was 1917 to 21. So that's us coming through here. 17 to 21, right? We kind of got the tail end of that. We'll talk about that tail end shortly as well. But then the next post that came up was number 3. Came up separately, not through there, in 1923. And they kind of contaminated each other, and that's how they reconstructed this kind of pattern. And number 4 was the collapse and explosion in 1924. And then you have number 5 coming in 1929, 31, 32, and 34. It was refilling eruptions, refilling of that pit. And finally, number 6 and 7 is 1952 and 54, 2 branches of something that had gone through some earlier lava. Right, the idea being that you basically had pulses of different batches of lava coming up, magma coming up, and not one continuous connected system. And to the left here is his comparison of the connected system we've had recently and likely still have again now. The connection all the way to Pu'o'o and East Rift Zone. And that pathway was worn open, we believe, by those 35 years of eruption. An upper pathway to a shallower chamber and a shallow eruption at the summit area here. So we may have more of this configuration, right? But it doesn't mean we can't have some version of both at the same time, right? Or if we could have this going on and still have a separate batch that might come up. It may not exactly connect all the way through to this eruption site, right? That's one possibility of the signals that are showing in a volcano. Or it could be that it's coming up and there's some kind of epimagma per se, some plug of some kind, or something that's separating it, or buffering it, and blocking it. And I really don't know. And that's something that we have heard HVO write about and Volcano Watches about. Maybe that could be something infrasound could help you figure out pathways of magma and shapes and those kind of things. Not just infrasound, but the seismic and different kinds of seismic, ambient seismic signals and etc. Those kind of things. Right. So that's the patch of it right there. Right. So in the end, we have these pulses that came through, and so there's more done. And let's step forward here and show you guys a combination figure here. So these are from USGS professional paper 1806, and on the left here we've just recolored it to make it the same as the right. This is originally from two different plots, right? But what we're showing here on the left is the magma filling rate, cubic kilometers per year, and on the bottom is intervals of time. So it starts off at 1823 to 25. Over here is 1840, after which the rate of filling drops down significantly. So really from 1840 all the way through 1918, with some error in this variation, you have a much lower level of lava supply, right? So this is where this argument comes in of, well, we have a much less connected system. It's not just flowing through all the time, it's coming up in batches instead because it's less connected. Okay, so that's up to 1918, and over here to the right is following 1918. So you can kind of see that following that, and this is around 1952 or so, right in here. It's kind of low, and then it picks up again, and more recently, the more recent era has shown supply rate way up here. So we're at a much higher time where that puts us in a very different realm to what was happening 100 years ago, right? As far as supply rate goes, which is important for what you see at the surface. But still, you can see that putting in context, 1921 was really in the middle of that low spot, right? So it's really thought that there could be just different batches coming up, and they might have been more gassy, and maybe that's why they were more olivine rich. Olivine crystals take time to grow; they grow pretty slow in the magma chamber as well. Not always. There's been more recent research on that, but the bigger they are, usually the longer they have to be at that optimal conditions to grow. So to have bigger ones, you'd imagine that lava, and for the lava to be reported to have been viscous as well. Jaggar called it more viscous. Maybe it was a separate batch, or like the dregs, like that last batch, right? In fact, there were pulses in January, December, February, and March. And he speculates somewhere in his writings that there are essentially 3 pulses of the last big slugs of gas, perhaps, that were a little bit more separated coming to the surface and causing this 3 pulses, which we'll show you guys shortly as well in the signals. So that's the magma supply right there, and we're almost done here. But here is the plot, looking from 1912 on the left to 1926 on the right. So our 1921 period is right in here. On the bottom is a tilt. So there's some variation in tilt. You see there's a lot of gaps. You see there's some regional uplift happening outside, and you see the smaller signals on top. In the middle here is a lava lake level. That's what the red plot shows. And on the top is earthquakes. So there are not a whole lot of earthquakes, really, as far as notable swarms connected to this event. There was adjustments of Mauna Loa in particular, it seems like, but also Kilauea, to the lack of pressure. But we have to basically zoom in to this little bump right in here. But you really see that for 4 years, the lava level was by the rim, by this red line up here, and before that had been visible, but lower, right? At elevation of, in this case, 3,100 feet or so, right? So we today are still down way over here. This is where our lava level is compared on that graph, more or less. Okay, so we're going to zoom in. First we'll zoom in. There's a version of this that goes a little bit less time. So 1919 on the left, 1921 is right here in the middle. That's this hump right in here. And we did follow the Mauna Iki eruption and draining, all that event. That was the last time that we had high lava overflowing a crater. So from that time, mid-1920, when eruption ended, right around here, it was a long eruption. We're recovering, and then we come up in 1 pulse, 2 pulses, 3 pulses right there, and go back down. And maybe another pulse, but it doesn't make it to the actual lip of the crater. And this over here is 1924, when the whole thing blasts out and nothing's ever the same in Halemaumau again from that point forward. So, okay. You can zoom way in. I've drawn this was the first image I showed you guys on the bottom right here. That's where the black line shows where it goes. Second image I showed you guys just right here. And zoomed in and stretched it out to show you guys in a little more detail what was going on here. Okay, so, because we're interested in something like the tilt, right? How much tilt variation was it? Well, this is showing it in seconds and not microradians, so there's another factor of 5 something that is applied here, right? So, but you can see that in mid-May there is a rise in the tilt, and there's lots of these rises. So you can see that these probably did correspond to the changes in lava level to some degree. If you look a little higher up here, lava level, highest at the surface there, almost reaching the rim, right in there, which is an idea that's not new to us, since we've discussed in the past the publication of Matt Patrick et al. Of using the 2018 lava lake as a piezometer, as a pressure gauge for the whole lava system and went all the way to pool. So there was a little bit of tilt signal, but there weren't that good. I mean, this was early days of the signals. They were looking at lava level, and this was mostly documented by what you guys saw. Jaggar walking around on foot, taking his camera and notebook around. So that is a 1921 eruption.